Good afternoon, all of you. So, we were discussing about oxidation number in the last class, and we studied a set of rules to find out the oxidation number of atoms in compounds and even ions. So, today we are going to find out some oxidation numbers of few atoms in compounds. So we will be finding the oxidation number of sulfur in SO4 minus, chlorine in ClO3 minus, and manganese in KMnO4 and chromium in Na2Cr2O7. So how to find the oxidation number of these elements in the compounds? That's what we are going to do today. We are thorough with the set of rules by yesterday. So first we are going to find the oxidation number of manganese in KMnO4. For that, what we need to know is about the oxidation states of other atoms in the same group. So if we want to find out the oxidation number of manganese, we need to have an idea about the oxidation state of potassium and of oxygen. And yesterday we told a rule that if there is no net charge in the ion or compound, then the sum of all the oxidation states of each atom will be equal to 0. So sum of all the oxidation states should be equal to 0. That we can use to find out the oxidation state of individual atoms in a compound. So we need to know about the oxidation state of other atoms. So potassium, the oxidation state is +1, and oxygen it is -2. And we can assume Mn, the oxidation state of Mn, to be X. And we are formulating an equation like this. So substituting the oxidation state of potassium to be +1 plus the oxidation state of Mn, we are assuming it to be X, plus the oxidation state of oxygen. One oxygen will have oxidation state of -2. So there are 4 atoms. So we are taking 4 into -2. And the total of this, or the sum of the oxidation states of all the elements, will be equal to 0. So that equation we are adding here. Sum of oxidation state of potassium plus sum of oxidation state of manganese plus oxidation state of oxygen will give us 0. Hence we can find out the oxidation state of manganese here. So solving the equation, 4 into -2 will become -8, and +1, -8 plus 1 will become -7. So x plus -7 is equal to 0, or x minus 7 is equal to 0. We are taking this -7 to this side, it will become x is equal to +7. So the manganese oxidation state in KMnO4 is +7. Like this, we can find out any oxidation state in any compound. We are finding SO4 minus and ClO3 minus now. So SO4 minus, and this 2 minus is the net charge. It's not the oxidation state of oxygen which is shown here. The 2 minus is the net charge for SO4. So SO4 minus, we can write the equation like this. X, which is we are considering that of sulfur. So as we need to find the oxidation state of sulfur, that we are giving it as X. So X plus 4 into -2, which means 4 into oxidation state of oxygen, will be equal to the net charge, or this, the net charge. If the net charge is not there, we have to consider 0 here. If net charge is there, then we need to add all of this, and the sum will give us the net charge. So x plus 4 into -2 gives -2. So this equation when we solve, 4 into -2 will become again -8. So x minus 8 is equal to -2. Taking this 8 to this side, it will become +8. So 8 minus 2 will be 6. So the oxidation state of sulfur in SO4 minus is 6 plus, or positive 6. ClO3 1 minus or ClO3 minus, and minus is the net charge. So we can write the equation like x plus 3 into -2. There are 3 oxygens with the charge -2. So 3 into -2 plus x will give -1, or the net charge. So again x plus 3 into -2 will become 6 minus, or the -6. So x minus 6 is equal to -1. Taking this 6 to this side will become positive 6. X is equal to 6 minus 1 will be 5. So the oxidation state of chlorine in ClO3 minus is plus 5. The last compound, for example, which is Na2Cr2O7, in that we need to find the oxidation state of chromium. So how it can be done? 2 into 1. The oxidation state of sodium is plus 1 as we know. So 2 atoms of sodium are there. So 2 into plus 1 plus 2x. Why we are giving 2x? Because there are 2 atoms of chromium. In previous cases there was just 1. So we give x. So as there is 2 atoms present, we are giving 2x. So 2 into 1, which is of sodium, plus 2x, that of chromium, which we don't know, and we comes to 7 into minus 2 as the oxygen, the common thing. 7 into minus 2, that will become 0. So the total will become 0. So we are substituting that in the equation. Hence solving the equation, 2 into 1 becomes 2 and 7 into minus 2 becomes minus 14. Minus 14 plus 2 will become minus 12. So 2x plus minus 12 is equal to 0. So we are taking that minus 12 to this side. So it will become 2x is equal to 12. Hence x will be equal to 12 by 2, which is equal to 6. So x is equal to 12 by 2 is equal to 6. So the oxidation number of chromium in Na2Cr2O7 will be equal to 6 or positive 6. So this is how we solve the oxidation states, or we find out the oxidation states of each element in the compound. So if we consider the periodic table, along a group, most of the elements show same oxidation states. So along a group like Li, Na, K, etc. shows plus 1 oxidation state, beryllium, magnesium, calcium, they show plus 2, the carbon shows plus 4 oxidation state, oxygen shows minus 2, sulfur shows minus 2, fluorine, chlorine, bromine, etc. shows minus 1. All those are common throughout the group. But there is no strict rules, or there is no necessity to show same oxidation state. They show different oxidation states also. But usually we can see a common trend in throughout the group of periodic table. And the highest oxidation state which can be shown by a group is given in your textbook as a column like this. So highest oxidation number which can be shown by first group is by Na, which is plus 1. So second group it is plus 2, 13th it is plus 3, 14th it is plus 4, 15th it is plus 5, 16th is plus 6 and 17th is plus 7. Usually the oxidation state shown by this group is minus 1, but it can show an oxidation state of plus 7 also. And in this case also usually it shows minus 2, but they show plus 6 also, which is shown by sulfur. So this is the table which is given in your textbook. Do make note on this and read it carefully and ask me if you have any queries about it. So now we are going to the next portion, which is redox reaction in terms of oxidation number. So redox reaction we have defined through many methods like the electron transfer, the competitive electron transfer, all those we have seen. So it's another definition for redox reaction we are giving in terms of oxidation number. It is actually similar to that of electron transfer only. It is actually telling that only, but we are just defining it in a different way. So the idea of oxidation number has been applied to define oxidation, reduction, oxidizing agent, reducing agent and the redox reaction. And the oxidizing agent is known as oxidant and reducing agent is known as the reductant. So this is a redox reaction. Zinc plus HCl gives zinc chloride plus H2. In this we do know that there are two native forms available, which are zinc, and in the product form it is H2. And both of them will have oxidation state of 0 as we discussed. And in the chlorine, if you see, chlorine is not changing its oxidation state at all. Here also hydrogen is plus 1, so chlorine will act as minus 1. In this case zinc is showing plus 2 oxidation state and chlorine, two of them will show minus 2, hence one chlorine will show minus 1. So here it is minus 1 and even here it is minus 1. So in both states chlorine is showing minus 1 oxidation state or same oxidation state. So the change is for zinc and hydrogen. Zinc by giving out its electrons becoming zinc 2 plus and hydrogen from plus 1 to 0 it is changing. So the redox reaction involving change of zinc and hydrogen. And now we will be speaking about the redox reaction in terms of oxidation number. So in terms of oxidation number, oxidation is an increase in the oxidation number of an element. So zinc is from 0, it is becoming plus 2. So plus 2 from 0 is an increase in oxidation number. So zinc is undergoing oxidation. And hydrogen from plus 1 it is getting transferred to 0. So plus 1 to 0 is decrease in oxidation number, hence it is a reduction. So hydrogen is going on through reduction and zinc is going through oxidation. If you look closely, you will understand that it's actually the same thing what we told in electron transfer. If you compare that, it is actually the same thing. But there we spoke about electron transfer, here we are telling about the oxidation number. That's all. Actual oxidation number change is because of the electron transfer only. So both are same. So here is another example, H2 plus O2 giving H2O. Here both of them are in native form or elemental form, hence their oxidation states will be 0. And after the reaction, after combining, hydrogen will be transferred to plus 1 oxidation state and oxygen from 0 to minus 2 oxidation state. So here hydrogen increases its oxidation state from 0 to plus 1. Increase in oxidation state, that means it is oxidation. So 0 to minus 2, decrease in oxidation state is occurring for oxygen. So decrease in oxidation state is reduction. Next example, H2 plus Cl2 gives HCl. Here also the reactants are in the native form, hence they will have oxidation state of 0. And hydrogen transferred from 0 to plus 1 and chlorine is from 0 to minus 1. Increase in oxidation state for hydrogen and decrease in oxidation state for chlorine. So increase in oxidation state is oxidation and decrease in oxidation state is reduction. Chlorine is reducing, hydrogen is oxidation. And this example you need to try by yourself and find which one is oxidizing and which one is reducing according to oxidation number. So oxidation, an increase in the oxidation number, reduction, decrease in oxidation number. Whoever is oxidizing, that is the oxidizing agent, a reagent which can increase the oxidation number, and reducing agent, an agent which lowers the oxidation number. So that is a reducing agent. And redox reaction is a reaction in which involvement of change in oxidation number is there, then we can tell it's a redox reaction. All these things are known to you. So with this information, you try to solve the last question which I gave. Now we are moving on to the next portion, which is types of redox reaction. There are 4 types of redox reaction, which are combination reaction, decomposition reaction, disproportionation reaction, and displacement reaction. And in displacement reaction, we do have 2 categories, the metal displacement and non-metallic displacement. So first we will discuss about combination reactions. So combination reaction is a reaction where 2 or more elements or compounds combine to form a single compound. So from the name only we can understand it's a combining process. So 2 or more elements combine together to form a single compound. So that is what combination reactions are. So this is the form of combination reaction. A plus B is equal to C, and one condition is that A or B or both of A or B must be an elemental form. So such reaction will only be redox reactions. So as we are dealing with redox reactions now, so A or B should be elemental form. So an example is given here, C plus O2 gives CO2. In both of these are elemental form. So it's a redox reaction also. And elemental form, they have 0 oxidation state, and when combining, carbon will be in plus 4 oxidation state. As oxygen is more electronegative, it will have a charge of minus 2. So 0 to plus 4 increase in oxidation number, hence it is oxidation, and oxygen 0 to minus 2 it's a reduction as it is decrease in oxidation number. And it's a combination reaction also. Two different elements are combining together or atoms are combining together to form a single compound or a single product. Another example is Mg plus N2 gives Mg3N2. So hence it's a redox reaction and it's a combination reaction as it is just one product. This is also another example which is given in your textbook. It is a redox reaction but it's not a combination reaction. In combination reaction, two different compounds should combine to form a single product. As there are two products, it's not actually a combination reaction but it's a redox reaction, and one out of two is in elemental form also. So next is the type of reaction which is known as decomposition reaction. As I told, decomposition is just opposite of combination reaction. So a decomposition reaction leads to breakdown of compound into two or more different compounds. At least one of them must be elemental state. In combination, we have seen this type of reaction where two of them combine together to form a single compound. Decomposition is just opposite of this. One compound is splitting up into two different components. So that is what I told, it is just opposite. So in decomposition, this is the kind of reaction where a single compound is splitting into two different components. And one of them should be in the elemental state as we told in the combination reaction. So this is another example. All of them are redox reactions where the plus 1 H2 is converted to 0 where it is decrease in oxidation state, and minus 2 it is converted to O2, it is an increase in oxidation state. So with that you can understand all the redox reactions. Here also one component it's splitting up into two different components where one of them is in the elemental state. In both the cases, both of them are also in the elemental state. That's all about decomposition and combination reactions, and tomorrow we will be discussing more types of redox reactions. So now you have a work. Find oxidation states of these marked elements in this compounds and submit. Thank you.